Okay, so I introduced this new topic the last day, CI/CD, continuous integration, continuous deployment. And the idea behind it is when you've got a team of developers working on a project, you've got to continuously integrate the uh, output of each member of that team, which presumably is code, integrate it into a central repository to make sure that your application is still functioning, irrespective of what the stage of the development is, even at the earlier stages. And if the application is at a state where it can actually be deployed, then you need to continuously deploy it first to what we call a staging environment, which is an environment that is available to all members of the team, and ultimately deploying it to the production environment. And we want all of that, the integration process, the automated testing, the deployment, we want all of that to be uh, automatic or automated, let's say, as opposed to requiring some manual intervention. So that's the kind of high level idea behind CI/CD. And I also gave the reasons why it's important and really kind of all makes sense, really. So all that's left is to look at some of the tools or a tool that can help us in achieving these objectives of continuous integration and continuous deployment. And the one that I've chosen to use and have been using for the last couple of years now is the GitLab platform, which is quite popular in the industry. Although, as I said last week, there are a lot of alternatives to it. And so we started looking at GitLab and to use GitLab. And again, some of the practices when we use GitLab are very similar to the practices that you would use for other CI/CD platforms. So it's quite easy to transition from using one platform to another. There may be slight differences in the syntax and style, but other than that, it's not difficult to transition from one tool to another. With GitLab, what you do is GitLab, as I said the last day, it's actually an entire kind of project management platform. It's not just about CI/CD, but we're only interested in the CI part, and we're also interested in the repository part. And so what you do is, let's see if I pick up the story. So I'm saying here that what you do is you create a pipeline, and a pipeline describes the different steps that you want to have automatically carried out each time a team member essentially pushes an update to the repository that's storing your code. It actually doesn't have to be a GitLab repository. You could integrate this with GitHub and with other Bitbucket, which is another Git repository. But just for convenience, we're going to use GitLab's own repository. So when you upload a change to any of the code within your project to your GitLab repository, we want that to trigger the execution of what we call a pipeline. And a pipeline is broken up into stages, and stages are broken up into jobs. And essentially, we want to execute all of the jobs, all of the relevant jobs that are part of our CI/CD pipeline. You describe this pipeline in a file, in a YAML file, which by convention is called gitlab-ci.yaml, although you can call it something else, but if you do, then you need to configure your project so that it knows to look for this alternative name, but we'll stick with the standard one. And so here's the simple example of a GitLab YAML file, GitLab CI YAML file. And we looked at this the last day. So YAML, as you know, is kind of a cleaner version of JSON. There are very close similarities between them. So in the GitLab YAML file, typically at the start is where we describe what are the different stages that make up our pipeline. And I did say to you, and I will repeat again, you've got to be very, very careful about the use of indentation and alignment in your YAML file, in any YAML file, not just this YAML file that relates to the GitLab platform. So in this example, we have three stages that make up our pipeline. And then the rest of the YAML file is describing the different jobs that are associated with each stage. And so in this example, job A looks like it's part of stage one. Job B and C are part of stage two, and job D is part of stage three. And again, it actually doesn't matter the order in which you put these jobs, but I guess it makes sense from a readability point of view that you would try and put them in some order, but it doesn't actually matter. And so the execution of this particular pipeline is going to begin at stage one. And so it's going to execute job A. And if that runs successfully, it's going to go on to stage two, which are these two here. And because we've got two jobs in the same stage, they're actually going to be executed in parallel. So you can't have any kind of dependency relationship between them. And if they all work successfully, then it moves on to stage three, and there's one job in stage three. If we even had a stage four and there were no jobs in stage four, that doesn't cause any problems. It just ignores it. So hopefully everybody has played a little bit with this in last week's lab. So you've got some tiny bit of experience of this idea of running a pipeline. When you log in to the GitLab and go to the project itself, which is in my case here. Here's my little demo project. It doesn't have any source code as it turns out. All it has is just the YAML file. And you just need to get familiar with how you navigate around this GitLab tool. So this is just the repository part of it. But if you move the mouse to the left, you get this pop-up. And there are lots of places here that we could look at, and that reflects the fact that GitLab is an entire project management tool. The two parts that we're particularly interested in is the build part. That's where we can see our pipelines and our jobs. And we're also going to be interested in the settings part. If I go down to, am I logged in? I think I am, sorry. Just one sec now. The settings here, and there are tons and tons of settings, but the only ones that we will be interested in are the settings related to CI/CD. I'll look at those in a while. Just to go back to the build part and pipelines, and we can see the result of the execution of our pipeline. So it looks like this particular execution ran three stages, and we can then, if we click on any stage, we can see the jobs in that stage. And if we click on the job, we can get a look at the console log generated when that particular stage executed. I know now I'm going back over everything that we kind of already know, really. That's that's fine. That's an example of the pipeline execution. Each job in a pipeline, its execution environment is a Docker container. And we've got proof of that down here. We can see that for this sample pipeline from the previous slide, the container that's being used by GitLab is a Ruby-based container. It's just the default one that's chosen. I know my pen a bit active there. Erase that. Oh yeah, that's okay. So it runs a job inside a container, and we refer to that container as the build container. I don't mention it on this slide, but I mention it subsequently because it turns out there are other containers that we can have part of the job as well. So that's kind of links to all the Docker stuff that we've been using, which is kind of nice. You can control the image that's used by your build container. And so I'm showing that here in the top left part of the screen. So there's an image keyword that we can use in our job declaration, and there we can specify the actual image that we want to be used within the build container. And we've seen the BusyBox image before. I'm not specifying any version, which you can. So it's going to pick up the latest version of the BusyBox container. So that means now that these two build commands here, which are just simple echo commands, they're going to be executed inside a container that is based on the BusyBox image. And we can see down here the kind of console log from this particular job, and lo and behold, here it's actually mentioning that it's using the BusyBox container, the BusyBox image, sorry, as the container image. Okay, new stuff. So we can declare and use variables in our pipeline. There are, as it turns out, four sources for variables in a pipeline, and the ones that we are actually really interested in are number 3 and 4. But well, in fact, we're interested in number 1 as well. So there's a whole bunch of predefined variables that are kind of useful to us. I'm giving you a URL there, and if you go to that URL, you'll get a list of all of the predefined variables that are available to every pipeline execution. There's actually way too many to talk to them, but there's a small subset that we will use and that are commonly used, and we'll see evidence of that later on. That's fine. You can define variables at the job level. I don't tend to do that, but you can. You can define variables at the pipeline level, which means any pipeline level variables are available to every job in the pipeline. And we will see an example of that in a moment. And there are also what are referred to as environment variables. These are also extremely important. If you've got specific values that would be considered sensitive values, let's say, for example, login credentials, that kind of idea, or tokens, any of those things, you don't really want to declare those as pipeline variables, because then anybody can actually see the values for those variables in your YAML file. So that's probably not a clever thing to do. So instead, we would declare that kind of sensitive data using GitLab's environment variables option. For pipeline variables, so this is an excerpt from our YAML file, and this is how we declare pipeline variables. We typically put it at the very top of the YAML file before the stages part. And so the variables are just essentially just key value pairs. So it's the name of the variable, the value, which can be a string or a numeric value, can be anything really. So it looks like I'm just declaring three environment variables here. This is kind of an interesting one. My Docker Hub username. We'll see that actually in this week's lab. This variable here, it's actually referring to another predefined variable. This is a predefined variable that's available to um, every GitLab project. Maybe I'll come back to it a little bit later on, but that's what it's. Any variable that begins with CI underscore is referring to a predefined variable. So, and there's conventionally the variable names are all uppercase, and we can use an underscore maybe to break up the name if we want to. Although I think that's only a convention, but we may as well follow the convention. And so once I declare these kind of variables, I can reference them in my jobs using this kind of syntax here. Just wrap the variable name in curly braces preceded by the dollar. I think the curly braces are actually optional. I think you can leave that out. The dollar sign certainly isn't optional. Because you can see here where I'm referring to a predefined, oh yeah, I'm using the same syntax actually up here. Okay, so that's pipeline variables, and really it depends on the project as to what pipeline variables you might need in the rest of the in the various jobs that make up your pipeline. But syntactically, this is how we do it. For environment variables, these are the ones that contain potentially sensitive data that you don't want to expose in the actual raw YAML file. So the way you declare those is, I'm just kind of showing you on the screenshot here, but if I go to my GitLab sample project, not sure if I have any declared now on this one actually, but if you go to the settings section down here, go to CI/CD, and if you scroll down to the variables part, click on that, and then you can just declare any environment variable that you want to by, where's the option? Just add variable here. Okay, and you just fill out this little form on the right. Now in our case, it'll always be a variable type. We can leave that as all environments or as default. Click make it visible. Don't select any of the other options. In fact, untick this one. Untick all of those because they will cause problems, and we don't really need a description. And the key then is the actual name, and the value is obviously the value. Okay, so that's how you declare environment variables. And then whatever name you use here, whatever key you use, you can use that key within your jobs just as you would refer to ordinary pipeline variables. Yeah. So that's that. And in this week's lab, you'll get some practice declaring environment variables and using them in your pipeline declaration. The next aspect of this is probably, I'm not sure if it's unique to GitLab. I'm sure there's a version of it in the other CI/CD platforms, but they may not use the term services. So the idea of a service is we're saying here that a job's script, its build script, is executed inside a container. We know that, right? And the image of that container is specified using the image keyword within the job. but you can actually have additional containers associated with a job. And those other containers, as well as the build container, they are all on the same Docker network, which we know a lot about. And so you can have references in your build script that's referencing the containers that are actually service containers. Okay, you can have they can communicate with one another. So these additional containers can be created and made available to the build container I'm saying here, using this services keyword in the job declaration. Now, if your build script wants to refer to one of the containers that are running as service containers, then the question is what host name would it use for those service containers? And the default is that you use the name associated with the image of the service container. You use that as the host name. So for example, if you had a service that was running image X version this, then the host name for that container will just be image X because that's corresponds to the image name. If the image name is something like this, which you can often get, then the host name is you just use a double underscore in to replace the slash in the image name. Uh, do I have an example? Yeah. So if I just switch over to VS Code, actually, let's see, do I need to? Oh yeah, if I load up my sample little project. All right, now just give me a sec. So if we look at this one here, so the base image, sorry, the build image is this one here. So it's just a simple base kind of Docker image that happens to have the curl utility installed on it. So my build script, this stuff down here, is going to be using the container that's based on this image. And my services containers, I've only got one, but you can have many. The container seems to be using the Nginx web server, which again, we know a lot about. The echo command is okay, but I've got a curl command here, and I'm curling the uh, web server whose domain name or host name is Nginx. And that is actually going to be this container here. So this curl command, the response back from the server should be the default Nginx homepage. Yeah. And so if we actually push this, so I've played around now a little bit with this. So I've made some changes to it. So I still got stage one, two, and three. I've still got job A, which is part of stage one. It's not, it's just doing echo commands. Job B is the one that we're interested in. I've commented out job C for now, and job D is pretty standard as well. Okay, so I've got job A, B, and D. So if I now just make a fake change to this, and if I push to, yep, if I push to GitHub, let's call it demo. So this here in VS Code is a nice convenient way of doing a push. And now if I switch over to GitLab, and go to my pipelines, and why did that not work? I should see evidence of the new one here, but it's not showing up for me. Let me let me do something like make an actual real change. Let's say just add a stage. I mustn't have committed the previous one properly. My mistake. Not to worry. I'll leave that as it is. Okay, back again. Okay, looks a bit healthier. So it's working its way through the different stages. So it's the second one I'm really interested in. And if we scroll down to the actual curl command, or scroll up in this case, so here's the curl command, and we kind of recognize this. This is the actual home page of the default homepage of the Nginx server, and it would have been a 200 status response, so that would all be successful, and so that's why the job completes successfully. So it's not a typical use case now of services though, but it does illustrate this idea of services. So it's just a way of creating additional containers within a job and making those containers available to your what we're calling the build script. And you can have more than one service container. Uh, a use case for this, and it's one that you'll see in this week's lab, is what's called the Docker in Docker image. So just to sidetrack now for a second. So there is a Docker image called the Docker in Docker image, and that image contains an installation of the Docker engine itself or the Docker server. We know now that there are two parts to the Docker platform. There's the Docker client and the Docker server. The Docker client or the CLI uh, is used when we type commands at the command line. We're using the Docker client there. But behind the scenes, that Docker client is communicating with the Docker server, which is running locally on your machine. Now, if we want to simulate that inside a pipeline, then we need to have a container that is running the Docker server or the Docker engine inside it. And that's where the Docker in Docker image comes in. It actually will achieve that for us. So if we look at this sample here on the right, so I'm for the service container, I'm using the Docker in Docker image. So that container is going to be running the Docker server for me. The build script is using the Docker CLI image. That's the image that just contains the client side. And so my build script, I can use Docker commands and they're going to run successfully. So I'm doing a Docker pull. That's okay. That's going to be pulling down from my or a Docker Hub account in my account in this case. But this Docker pull command won't work unless there is a Docker engine or a Docker server available to the Docker client. And that's going to be satisfied by this here. And then I'm doing a Docker images just to prove it. So that Docker images should show up this image as being installed locally within this pipeline job. Yeah. So again, if I switch back to here, and I think that's my job, this job here. Let's comment out this just to speed things up because we don't really need it. And if I now do commit, demo Docker and Docker, and push that up to GitLab, trigger the pipeline. While we're waiting for that pipeline, if I scroll down here, uh, you'll see examples here of a pipeline execution where nothing happened. And if that arises for you, then the reasoning behind it is that there is an error in your YAML file. And if you click on this here, it will take you to a page that will explain, you know, where in the YAML file it has found essentially a syntax error. Okay, so that's just something useful to know. So it's now running stage 2, which is my job C. So it's pulling down images from Docker Hub. So that's obviously takes time. Okay, looks good. And if we look at the detail of the job, so here's the Docker pull happening. And, this is the kind of output we would have seen on our local machines when we were pulling down an image that hadn't been previously pulled. So it's downloading the image, the various layers of the image. And then we do the Docker images command within my build script. And surprise, surprise, it's showing me that, this image has been downloaded locally within the pipeline job itself. So that's a very typical use case for the services aspect of pipelines. And if you don't have time to do it now, but if you simply comment out, sorry, this one here, if you comment out, this bit here and run or push those changes when the pipeline runs, when this command runs, you're going to get an error and that job is going to fail because now this Docker client doesn't have a Docker engine that it can communicate with. Okay, that's the services side of GitLab pipelines. What I'm showing you here are pretty much all of the different parts of a job description. Okay, and we've seen some of them already. So, you have the job name, you have what stage the job is associated with, so they're mandatory. You can have a variable section for declaring local variables. I don't tend to use that. You have the script part, which we know about. That's the build script. You can have a before script section. So if the script is quite long, then typically the beginning of it, the first few commands in the script are typically kind of setup related stuff. And just from a clarity point of view, those setup commands could be put into a before script section. And you'll see the before script being used in this week's lab. But so the commands in the before script, obviously, they are executed before the commands in the script section. And there's also an after script section, which I don't tend to use, but you can take some of the commands, some of the latter commands in the build script, you can delegate them down to the after script section if you want to, if the nature of what they do is kind of cleanup related stuff. There's the artifact section, which we won't use, but it can be useful. The artifacts section is if you want to share files between jobs, which would be a fairly common requirement, then that's what the artifacts section allow you to do. The only except is that's deprecated and that has now been replaced with rules, which I'll look at in a second. You can also assign tags to jobs. And the last one here, the when part of a job description, there's only one value that that actually has, which is called manual. By default, a job is automatically executed, but there may be certain jobs that you want the uh, or an individual to trigger the execution of it. So if you have a pipeline, let's say that's made up of 5 jobs, but you have declared job number 3 as being when its when option is set to manual, that what will happen is the pipeline will freeze on job 3. It won't execute job 3 or anything after it. And it's essentially waiting for a person to essentially click a button to trigger the execution of job 3. So we would say job 3 is a manual job, manual in the sense that it has to be initiated by an individual. Um, when job 3 then completes execution, and if it's successful, job 4 and 5 will execute automatically, provided their when option has not been set to manual. So that can be useful as well, the when option. Now, I said this part here, the only part is no longer applies and it has been replaced by what are called rules. And the rules allow you to control when a job should be executed. If a job does not have any rules, it's automatically executed. But there may be cases when you want it to be skipped for whatever reason. Um, so the syntax of it looks like this. Okay. So you have the rules keyword, and then you can have a number of rules, more than one. And essentially, they're all kind of if statements. Think of them like that. So here it looks like we're checking a particular default predefined uh, a predefined variable. It doesn't have to be, can be any variable. Um, and we're checking to see is it equal to a particular value. This variable here, the CI commit branch, that variable will be assigned the name of the branch that you have pushed the most recent change to, which by default is the branch called main in GitLab. But in general, this looks at the the branch that was committed to, and it's checking to see was it the branch whose name is develop. This is what this rule is saying. And if that condition is true, then this job will be executed. If the condition is false, the job won't be executed. If you've got a number of rules, then essentially GitLab looks to see if any one of those rules is true, and if any one of them is, then it executes the job. Okay, so rules allow us to control, to have more kind of fine-grained control over the the execution or the skipping of a job. These are the typical kind of use cases. You want to run a job when the commit is for a certain branch. I've just shown you an example of that on the previous slide. If the commit is a merge request, you want the job to be executed or not. It could be an equals condition or a not equals condition. The commit is tagged in some way. Well, all of these examples are related to the nature of the commit, but it doesn't have to be that. The condition can be anything. As I said, you can have multiple conditions. And if we just do a demo of that, if I go back to here. Now, just to use that develop branch option, if I go back to this job here, And I'll just take out this one just to speed things up. So the rule is if the commit was made to the branch whose name is develop, then run this job. Otherwise, don't run it. Now, if you can see at the bottom, let me just try and make it clear to you. In VS Code anyway, you can see what branch you're currently in. If you look down at the bottom left-hand side, essentially in the status bar of VS Code, it's telling you what branch you are currently on within VS Code. So I'm on branch main. Now that means if I do a commit of the changes that I've made to my project, then this job will run. Uh, this job will not run. Sorry, now. Uh, I want to enable this rule. So job job B will not run because this condition is not true. I will be committing to the main branch. I'm not committing to the branch whose name is develop. And this job will run because it doesn't have any rules associated with it. Just check that now again. Yeah, so let's see. So I expect job A and D to run, but not job B. So that's stage one, job A. And what's it trying to do here? It's trying to do job D. So it has skipped job B. Just let it run to completion. And you can see what branch you committed to from here. Sorry, beg your pardon. Here. This tells you what branch you're on. Okay, so if I go back to VS Code and if I switch branches now in VS Code, it's nice and convenient. I've already created the develop branch locally here. So if I click on the current branch, I can either create a branch, so you would type in the branch name there, or if you want to switch branches. So I'm going to switch over to the develop branch and I'll just make a fake change to my project, which happens to be always the YAML file, but typically would be the source code. So I'm just going to, let's say, do my trick with adding a stage. And commit these changes. Now, because I'm on the develop branch, I would expect job A, B, and D to run in this case. Now to do the push, I can't do the push from here in VS Code. I'll have to do it from the command line. Go back to GitLab, refresh my pipelines. So here's and voila, I've got an error in my YAML file. It's not good. The error message isn't great, but doesn't give me any hint. Just go back and do a manual check. That doesn't look healthy. I'm hoping that's the only error. Let's see. Yeah, let's gamble it. Now, it should be running 3 stages. This is not what I expected. Job B. Okay, well, it's running job B, which is the Nginx one. Why did it not run job? Go back here again. Oh, oh yeah, okay, I've commented out job D. So, uh, so it did work properly. It honored the rule that I gave it. If you don't specify a rule, then a job, I didn't specify any rule here, so that job is going to run no matter what branch you commit to. Okay, there was only one slide left in my set of slides, so for the lab for this week, it's a lab that you will need to submit. So if we just quickly, and in the lab, you'll be using GitLab to implement a CI pipeline. There's no deployment. Next week we'll do the CD part, but this is the CI pipeline for the user profile uh, application, web application that we played around with earlier on in the semester. So you need to work your way through that tomorrow. Okay, we're out of time, so I'm going to leave it at that, and I'll touch base with you tomorrow morning. Thanks. Bye bye.